Okay, so we started with section 1.4 last time, and we did the bulk of the beginning part of it until we got to this one page that has like a massive table on it. Big giant table. It's so big that it takes 4 slides in my PowerPoint presentation here. Whatever, my dossier presentation. We're going to go through these steps as we work the problem. Anything that you see that's outlined in a box, and it should be outlined in a box on my slide as well as in your notes that you've printed out, that's an actual button in your calculator, okay? That's what that represents. Anything that's not being represented in a box is representing some kind of a menu. So for example, if you see option number 2 here, it says select 1:edit. It's an option within the screen, it's not an actual button. We won't have to do all of these steps every single time that we work these problems. Some of them are a matter of we need to get our calculator set up to be able to do this, period. All right? So let's actually go through a few of the first steps to make sure that everybody's on the same track. So please have your calculator out. And if you don't have it with you here in class today, you're probably going to have to go through this video and go through all these steps on your own later to make sure that you have it down. So we're going to press the Stat button and select the first option that says Edit. And when that happens, you should see a screen where it has headers that say L1, L2, and if you keep scrolling across, they usually go out to L6. You don't need them to L6, but I think that's how far they go, okay? If you already have data in yours, like there's data in mine, it's got like entries in there already. What you do is you go up to the L1 or the L2 header, you just arrow up to it and you press Clear. Do not press Delete, that will erase the entire list and it will just disappear. I mean, like we can get it back, but Clear actually clears the list out. So we want clear lists to start with. So what we're able to do then is to put data into a table. And if you flip over to the next page in your notes, you'll see the data that we're going to put into the table. The data that we're going to put into the table is one of my brand new questions. This table shows the total number of positive COVID-19 cases diagnosed in Oklahoma weekly in weeks after April 1st. Okay, so this is early on in Oklahoma, really early, like right as you were starting to do all your stuff online with your professors last semester. Okay, so what you're seeing here is you're seeing 2 sets of data. The first one is going to go in the list L1, and the second data is going to go in your list L2. So you're just going to go down your L1 list and you're going to type in 0, 1, 2, 3, 4, 5, and 6. And then over in L2, you're going to type the COVID-19 cases number, which are the larger ones, 719, 1524, 2297, 2894, 3473, 4201, and 4852. Now, if you didn't miss any, hopefully you didn't miss any, like you should end up with the same number of entries in each list. They should match. If you've missed something, they're not going to match, and you'll know to go back and figure out which ones you actually skipped or something like that. Okay, so if we come back to our list of details, we have now gone through step 1, step 2, step 3, and step 4. All right, we've entered our data into L1 and L2. To get out of this particular screen in your calculator, you hit the second key and the mode key, which is right next to it, and that will put you back in the regular menu where you can add, subtract, multiply, and divide. Okay? It should be a regular blank screen, or maybe it's got some data in from something you did before. After that, I want you to hit the second key again, and Y equals. And when you do that, the title on this screen should say Stat Plot. And it should say 1 plot 1, 2 plot 2, 3 plot 3, 4 plot 4. Do you guys have that screen? All right, we're going to select the first one, 1 plot 1, and we're going to make sure that all of our lists and everything look correct. You need to turn it on, so you're going to have to press on top of the word on. You press enter on top of that word. You're going to have to decide what kind of a plot you want. So you have choices, but the one that we're going to be using is actually the very first one listed. It's a dot plot. Okay, just a scatter plot. So you're going to use the very first one. It will say something like X list and Y list. X list should say L1, Y list should say L2. Does anyone's not say that? Because if it doesn't, I'm just going to come fix it myself because it seldom happens. But yes, Martin.
Mine, like, I cannot enter in L1, like, it doesn't appear.
Okay, I can fix that too. So at some point, somebody deleted them. We're going to get back to the second for this insert key. And we tell it that all the digits right there. Really L1. Anybody else does not have L1 or L2, or not have them, not have it say L1 and L2 in the current place for the list? Okay, awesome. At the very bottom, you can select which of the different 3 types of dots you want it to show up as. So the first one actually looks like sort of an open circle. That's the one I use because it's visible enough. The second one looks like a plus sign. That's also visible. I think, for me personally, it looks a little distracting, so I don't use that one. And the last one looks like a dot. I think the dot's a little bit hard to see, so I don't use that one. But it's your pick. You can pick any of them you want. Okay, so you should have your plot one on. It says select on, make sure X list is L1, Y list is L2. Those things, and the plot one being on, those you're not going to have to change anymore. So all of these steps from here to here are a default now. We don't need to do them again, okay? So we just took out 4 steps from this crazy list that I just gave you. It's already done. So press Y equals. Clear out any equations you have. Mine has one, so I'm going to clear it out. Just clear things out. And then hit the zoom button and select option number 9. So, again, this is one of those unfortunate things that I don't have a display for you, but you should see a bunch of dots on your screen now. Do you see dots? Awesome. Does anybody not have dots on their screen? Okay, great. So this would be a visual description, right, of what happened during the first, or during these particular 7 or 8, whatever it was, weeks of the first data collection, right? This is the visual description of what's happening. So what we're going to actually do then is we would like to create the equation that connects the dots. I mean, yeah, like the equation itself is what everybody keeps, they always connect dots. You see that, right? Everybody wants to connect the dots, or at least try to. Well, we're going to connect the dots too. And the way that we're going to do that is we're going to use statistics. And we're not going to use statistics in the sense that you need to know how to do the statistics, but it's the statistics menu in your calculator. So if you hit the stat button, it's going to come up with a list of details. You're going to arrow over, it says edit calc tests. You need to arrow over until you're in the middle one, which says calc. Calc means calculations. It doesn't mean calculus, actually. It means calculating something. It's calculating things. And what you're going to see if you look down this list is lots of different calculations that can be made. And what this is going to do is this is you telling your calculator what kind of model you want it to fit to those dots. That doesn't mean that it'll fit it well, but the calculator is going to try its best based on what you tell it. What we're doing in this section is linear regression. That's option number 4. But we're going to do a lot more of these different regressions as we go through the rest of chapter 1. And in fact, in 1.5, when we started here in a little bit, we're going to do the EXP reg, which is exponential regression. So we'll do that later today. But for now, you want number 4, linear regression. So either arrow down and press enter on top of the 4, or just press the number 4. So what you should see now in your calculator is you should see in the regular screen, you're back in your regular screen, something about that linear regression. And I have to apologize because my screen may or may not look like yours. There's 2 different operating systems that are now in use on the TI-84 system calculators. Mine says this. Okay, by show of hands, whose calculator actually shows that on their screen right now? Excellent. So those of you who just raised your hands, about maybe 2/3 of the class, I'm talking to you first, and then we'll talk to everybody else who says it something else different later. Okay, so this is just for those of you who it actually looks like this. What you want to do now is to tell it where to put this equation. If I just press enter, it's going to create an equation. I don't have to do anything else right now. If I press enter, it will create an equation. What I really want is I want it to put that equation into the graph. And I can do that all at the same time if I take one more step. The one more step is that I have to tell it to put it into there. I do that by hitting, next screen, vars. It's the vars key. It's underneath the keypad up and down arrows. I want a y variable, so I go over to y vars. I'm working with functions. We always will be working with functions in this class. So we press enter on number 1, and we're going to select y1. If I press enter now, what will happen is that it will create the equation in my regular screen. It'll look a little bit funny. It'll say y equals ax plus b, a is this, b is this. But if you hit graph, or not graph, if you hit y equals, like go back into the menu, it will actually create the equation for you, all put together. So I'm just going to write down the equation that's showing up for the moment inside of mine. It's 676.036 x. Lots more decimals than that, but we always use 3 decimals. Write that down somewhere. Always going to use 3. 823.321. That's what the calculator says right now. Yes, Sarah?
I think you pressed the wrong button. I pressed the y equals button.
Okay. So let me look at your calculator where you are. You were one of the ones who didn't have the screenshot. It's fine. Okay? So stat calc is fine there.
Oh,
Okay.
because I saw that.
Yeah, okay, so if yours didn't look like mine and it just displayed that linreg on a regular screen, it looks like Sarah's. So Sarah says linreg ax plus b at the top, and then it says x list, y list, frequency list, store regression equation, and calculate. Okay, so whose calculator says that? Okay, so some of you thought that I was on the wrong screen before. I'm sorry about that. Okay, so here's what you need to do. Your X list needs to say L1. Does it? Probably does if it's been not used by anyone else, maybe playing with it for something else. Your Y list should say L2. Does it? Right, so it's associating L1 with X and L2 with Y. And then where it says frequency list, leave it alone. You don't need that one. Go down where it says store regression equation. The store regression equation is when you go through all the same key functions that I did a minute ago, where you hit vars, y vars, function, y1. So let me write this on the screen so that you have a copy of it too in a visual format. So right at the top, yours might say now linear regression equation. Something like this. It says X list, and it should say L1. Y list should say L2. Your frequency list should be left blank. And then does it say store regression equation? Is that what it says? Okay, and you're going to get that to say Y1. You do that by going through this. Vars, Y vars, function, Y1. Okay, so steps 17 through 20 then go into that. After that, you go down to the button that says calculate, and you press enter on that button. So highlight that button, press enter, and it will do the same thing mine did. It will create an equation for you, and it'll put it into Y1 in your calculator, and it should be this equation. Okay, if it's not, it means either you or I have typoed something into my list.
I got an A and a B, I didn't.
But look
But
at
I
Y,
got those numbers.
Sarah, hit Y equals. There you go. Yeah. So in the regular screen, it gives you what you're seeing there, but if you hit Y equals, you can see it all put together in one form. Yes. Okay, so does everybody have this equation? Okay. This is a model. Last time, we talked about what constitutes a model. An equation with a name. A description for the output. A description for the input, and an interval for when the input data is relevant. The only thing we've done so far is an equation, right? So we need to fill in the rest of the details to create our model. We need a name. Your name needs to say f of x, g of x, c of x, k of x. I don't care what the letter is you use, but it doesn't say y equals. It needs to be in function notation. I default to f of x most of the time. Sometimes I get creative and I use like c of x because this is for COVID. Yeah, I use the letter in the problem. I know, it's crazy. So this is the name in the equation. That's what we have so far. The next thing we need to do is to determine the output, and you can usually tell it from the table that's been given, right? L2 is your output. So what is the output here?
Total COVID cases diagnosed?
Yeah, these are the cases that are diagnosed of COVID. So some description after this needs to say this. These are cases of COVID. Right? At the very least, you need the word cases. That is the bare minimum we're allowed to write down here for it to make any sense whatsoever. Okay? The next thing on that list of things I'm supposed to include said I needed to talk about the input. Well, the input is the L1. So over here on input, what is L1?
Weeks after April 1st.
I know, it's like we're just reading it out of a table, isn't it? It is, and that's exactly what we write down next. We say weeks after April 1st. If it helps you, you can put 2020. I think that you were all aware we're still in 2020, but you could put that. Sometimes it matters because we're dealing with data that's not 2020, and so we would put a date with that too, if it were given. The last thing I need is I need an input interval. The cool thing is that when you're given a table, the input interval is actually given there as well. It's 0 to 6. It's the inputs that you put into L1. So we would say 0 less than or equal to x less than or equal to 6. This is a complete model. Every single time, your models have to have all of those details and 3 decimal places. If you're missing parts of those details, you're going to have points taken off. If you're missing 3 decimal places or you're including 5 decimal places, there's going to be points taken off. Always 3 decimal places, always every single one of these details. And the reason is because every single one of these details is necessary in order to make any sense of the kinds of questions you're going to answer next. So part B says, what is the weekly rate of change in positive cases of COVID over this time frame? And we'll deal with the second part of that question in a moment. Do you remember what we said rate of change meant last time? I know you haven't done any homework in this section, so you probably haven't thought about that word, that phrase. Remember, Martin?
The slope.
It's what?
The slope of the function.
The slope. You got it. This means slope. So what is the slope of this function? 676.036. And this would be cases, right, per week. Because my output is cases and my input is weeks. That's the weekly rate. 676 cases per week. What do you think you might have to do to find the daily rate? Divide by 7, because there's 7 days in a week, right? So if we were to take the 676.036 and divide by 7, what would we get? I have this written down. We do. Our answer will be 3 decimal places.
You get
96.576, and then there's something else after that I think that's going to make it 7. Is it going to make it 7 when we round up? Okay. Yeah, and then this would be cases per day. Okay? So awfully close to 100, 100-ish almost cases per day. Okay, let's take a look at question C, part C. Part C says to estimate the total number of positive cases diagnosed on the 7th week and then on the 12th week. Well, my input is the number of weeks after April 1st. So if I want to know what's happening the 7th week, what do I have to do? Plug in 7. Right. So I called my function f, so I'm going to use an f here. Whatever you used is what you should use for yours too. I'm going to find f of 7 and f of 12, not 13, 12. Okay, here's the cool thing. Grab your calculator. Hit second graph. We've already done this before, but I know not everybody's had their calculators each time I've talked about it. Second graph. It should take you into a table that says an X column and a Y1 column. This is not the same place as the L1 and L2. Okay? But what it allows you to do in the X column is to plug in 7. And over there right beside it, it tells you what happens when you plug in the number 7. This is 555.571. That's what it says right now. It has more decimals. Does everyone's calculator say that? Is everybody been able to put the number 7 in? What's that? Arrow over on top of it. Like just press the arrow over, Paula. And if you go over there, it'll allow you to see the rest of them. Thank you for mentioning that. Yes. You want to actually put your cursor, or so to speak, on top of the actual Y value number, and it will spit out the more decimal places. Yes, Doran. If you were rounding and it gave you something that was zeros, you could still put a 0 in the placeholder for it, and that would be okay. But is your number still showing up the same as mine is, Doran? Or did you already do 12?
I just did 12.
Okay, cool. Yeah, so let's put the 12 in. Thank you for that. If you put the 12 in, you're exactly right. It gives just 0.75 at the end. So writing that, mine says 8935.75, and you're right, you will actually write a 0. Yes, you're always going to list it with 3 decimal places. So this is actually what we're getting. for those inputs, and those are the outputs that we get. But we didn't answer the question quite yet. When we're talking about rates of change, how things are changing, it is fine and appropriate to represent those with decimals in their answers, even though it's cases per week and we realize we cannot have, like part of a case, right? You either have, they're whole numbers, right? Nobody's reporting anything about decimal numbers of cases. That doesn't make sense. But when you're talking about rates, it makes sense. So it's perfectly fine what we did on part B. But on part C, when we write out our answer, this is actually 5,556 cases. Because it can't have 0.5 of a case. And on the other one, we're using just regular rounding rules. We have 8,936 cases. So what do I expect to see? Exactly what's on the screen. I expect to see an answer that has 3 decimal places, and then I expect to see the answer with the units that rounds it appropriately. Now, sometimes it makes sense to have points, right? Decimal points, right? If we were talking about money, we could have decimal points, but we couldn't have 3 unless you're a gas station. We can have 2, right? So the rounding isn't always to whole numbers. It depends on the context of the problem. Okay, so on part D, I'm giving you a little bit of real life situation. The actual number of positive cases on the 7th week was actually 5,532. On the 12th week was 11,510. The question is, how do your numbers compare and what can you deduce from this? So let's just talk about week 7 first. The actual real number is 5,532. We predicted 5,556. What would you say? We're pretty close. Yeah, so we're going to write that down. We were pretty close. On week 7. At week 12, what we had for real life is 11,510. Our prediction was 8,936. What do we say about that?
We were low.
Yeah, we were low, right? Our prediction was not as accurate. So you can say we were further off, or we were not as accurate, we were not as close, whatever language you want for week 12. It's not as close. We talked about a couple of words, I think it was last class period. Do you remember talking about interpolation and extrapolation? Okay. Both of these are extrapolation because they're both outside the interval 0 to 6, right? But 7 compared to 12, it's much closer to our interval, right? So the overall problem with this is that predictions a little bit out tend to work pretty well. The further out you predict things, the less certain that they become, or the less correct they end up being, potentially. So the issue is that week 7 is close to our data values. Maybe I should this. Week 7 is close to our input values. I think that's probably better. Generally, the farther out you predict, the less reliable your prediction is. Does that make sense? Okay. We're going to do one more type of prediction. So this is prediction we did already over here on part C, where we put in an input and it gave us out an output. We're going to flip it around for part E. According to your model, when should have, I don't think that's worded right. When should the total of positive cases have exceeded, that's where it's a misplaced something or other. I think it's supposed to go there. Have exceeded 30,000. Okay? When did we have 30,000 cases? That's what it's saying. When were there 30,000 cases, according to this particular model? Well, we don't want the input to be 30,000 because the input is the number of weeks, right? We want the output, the number of people infected, to be 30,000 in order to answer this question. So we actually want our function itself to equal 30,000. Now, what we don't want is we don't want to just enter random values until we, pass from 28,000 to 29,000 to 30,000. That's not our goal. Our goal is to find it precisely. And there's a really nice way to do that. We've also talked about this, but again, you may not have had your calculator in class when we did so because it was back in section 1.1. So here's how you do that. Hit y equals in your calculator. You've got your equation still in y1. Yes? Excellent. Arrow down to y2 and type in 30,000. Oh, I never had you do this. Actually, delete the 30,000 for a second and just hit graph because I never actually showed you that you could see your calculator plot the curve. Do you see how I hit the dots, almost all of them? Or they're really close, the connect the dots screen? Okay, good. All right, sorry, go back into y equals. I forgot to have you do that. 30,000 into y2. So visually, we have, let me put it here. We have a line that looks like this. And 30,000, you may not see it on your screen yet, I'll show you how to in a moment, is going to be it's going to be a horizontal line hitting my curve somewhere. My equation is a line this time. And what I'm really going to try and figure out is where do they cross? Because the place where they cross is exactly where I'm going to end up with 30,000 for the y value of my equation. Okay? So you've already put 30,000 in y1. That's great. And what I'd like for you to do is I'd like for you to just zoom out on your screen. So if you hit zoom, number 3 is zoom out. There's lots of ways to zoom out. This is one of them. And for the purposes of what we're doing, it'll work. My zoom out did not give me out far enough. I'm going to have to do it again. Okay, I zoomed out twice and across. And I see something very similar to what's on our note screen now. Do you see the horizontal line crossing your other line? Did you zoom out twice?
Yes.
Okay, got 2 people. You've only zoomed out once. Yep.
I've done that several times.
It looks like it's only done once. You have to press enter. I don't know if that's I guess. Yeah, make sure you press enter after you tell it to zoom out. Doran, have you got your work? Not yet? Okay. It's still on zoomed out again. So hit enter 2. You have to press enter. And you're fine. You just in that same screen where you were. Hit enter 2. Press enter. There it is. Yeah, so when you select for it to zoom out, you actually have to press enter when you're in the graphing screen in order for it to actually take effect. Okay, does everybody see theirs cross? Yeah. Oh, one more back. Sorry about that. Okay, we're looking at graph though. So we need to graph. So you don't have any question right now. So here's what we do, okay? something that looks like this now? Wonderful. Okay, so we're going to tell the calculator we want to find the intersection point of those. You do that by hitting second, the trace button, which is the calculate menu. So second, trace. And it's option number 5, the one that says intersect. And because this only intersects one time, when it prompts you first curve, second curve, guess, you just press enter 3 times. It doesn't matter where your cursor is on the whole screen. It's going to take you to the right place. And when it does that, it should be telling you X-min, not X-min, X 43.158. I'll round to 3 decimal places. And then, of course, the Y is going to say 30,000.
That's weeks.
The X is the number of weeks.
So we're way off.
Yes, we're way off because we've predicted really far out. So 43 weeks if that model had continued to hold. This is why modeling is so hard, because it doesn't last for very long in a particular situation, right? Too many variables affecting things. So it says, when, according to your model, the answer is after 43 weeks, we just use our regular rounding, after 43 weeks, that's our answer. Says the actual number of cases exceeded it on July 25th, which was between 16 and 17 weeks after April 1st. How close was our estimate? It's really bad. It's a terrible estimate, right? We were way off. I'm going to say way off. That sounds like a good mathematical term for today. We were way off. And the reason, I won't write it down, but you definitely should. The reason is because we predicted really far out. We have data here that only goes up to 5,000-ish cases. And we're trying to predict something that goes all the way to 30,000 cases. That's really far out from the data that I've already got. Does that make sense? If we were predicting, say, 7,000 cases, we'd probably be fairly close, because 7,000 isn't too far off from the 4,852 we already have. But 30,000, pretty far off. Any question on the problem? Okay. Okay, you haven't done the intersect then. So hit second trace. Okay, good. And then hit number 5 and press enter 3 times. Did it work? No. Okay. You don't have an graph that doesn't show cross sections after finance. There's no intersection on the line. So that means it's an outside. Yeah, so that is a caveat to the calculator, is that you actually have to see that intersection in the screen or it will not find the intersection for you. Visibly, you have to see it. All right, so that's it for section 1.4.